is on the website. You can go to OpenStax Tutor, and then you can log in, and you'll have your assignments. And there are two things. There's the assignment. That's the 14 questions, multiple choice questions. You can use any resource. You can work together. You can use the book. You can use whatever you need to answer those questions. Then there is another assignment that's the reading assignment, I think it's called, or reading something or another. That's not part of your quiz. That's sort of to help you read through the chapter, and there are questions that you answer as you go along through the chapter. I will count that in the end as some sort of extra credit. I haven't decided yet what that's going to be, but it'll be some sort of extra credit on your performance on those. Okay? Is that clear what I mean by that? I'll be more clear later in telling you how many points it'll be. I'm not sort of feeling that out right now. Y'all have any questions about anything? Yes, tell me your name. Kayla. Do it on Monday. If you didn't get registered yet, not a big deal, just use your quick code. Okay. Any other questions? Y'all never really seen me. Way upstairs. Moving all the way back here. Okay. All right, we're going to go on to conversion of units. We're going to use dimensional analysis to convert units. So very similar to what we've done before, but we're going to use to change from one system of units to another system of units. You got to do this on your quiz, and y'all did pretty well. As a class, by the way, y'all done darn well on that quiz. I'm really impressed. But they're going to get harder, okay? The quizzes will get harder as the material gets more complicated. Let's say, for example, we want to convert 28 meters per second to miles per hour. Now, you might just want to go to Google. And by the way, you know if you go to Google and you put 28 meters per second equals question mark, it does like the conversion for you. Y'all know that? I use it all the time. It's great. But you do need to know, because you won't have Google, you do need to know how to do conversions. First of all, you have to have conversion factors. Within the metric system, you have to know those, right? You have to know what centi, milli, and all those things mean. If you're going from one system to another, say from the metric to the British or back and forth, then I'll give you that. I expect you to know how many seconds are in an hour. Gosh, how many seconds are in an hour? 3,600, right. 60 seconds in a minute, 60 minutes in an hour. And in 1 mile, you probably know this, but in a mile, there are approximately 1,600 meters. There are 1,609 meters. So these are two conversion factors. Now, if we want to convert 28 meters per second, I set it up such that the units all cancel out appropriately and give me miles per hour. So my first conversion factor will be meters to miles. What do I put in the denominator? Where do I put the mile? Where do I put mile? In the numerator or denominator? I put it in the numerator, right. So mile goes up here, and meters goes down here. That's so that these units cancel out. I go to my conversion factor here. 1 mile is 1,609 meters. It's as if, since these two quantities are equal, it's as if I'm multiplying by 1. Obviously, I'm not multiplying by 1. I'm multiplying by 1 over 1,609. But these two quantities are the same. So it's as if I'm multiplying by 1. It's not changing the nature of the measurement. And then I do seconds and hours. What goes in the numerator? Seconds. So I do 3,600 seconds, 1 hour, and those units cancel out here, and I'm left with miles per hour. And that gives me 62.6. Notice my sig figs here. I have 3 sig figs here. I carry 3 sig figs here. That's because even though I only have 2 here, or it looks like I only have 2, how many significant figures really do I have for 3,600? It's a conversion factor, so I have an infinite number of significant figures. It's an infinitely well-known number. So I don't even consider it sig figs because it's as if I'm writing 3600 point, get ready, 0.0000000 all the way out, okay? So we don't consider the sig figs of those conversion factors. I think that's fairly straightforward. Students sometimes have trouble with this, converting units with powers. Let's say that I have 5.7 kilograms per cubic meter, and I want to convert it to grams per cubic centimeter. I say 5.7 kilograms per cubic meter. I know in 1 meter, gosh, how many centimeters in 1 meter? 100, right. By the way, you could also, if you like this better, you could also say 10 to the minus 2 meters in 1 centimeter. Either of those conversion factors would be okay. But the top one sort of, it makes more sense to me, so I'm going to use this. And then in 1 kilogram, there are how many grams? There are 1,000, or 10 to the third. But I'll write it as 1,000. Let's see, is that it? Does that give me the conversion? No, what am I missing? No. What's your name? Brent. What am I missing? Brennan. I'm sorry. Brennan, what am I missing? Right. I have a meter here, but I have a meters cubed here, so I don't cancel them out. So in order to do this conversion, I have to cube this conversion factor. And then that'll give me the appropriate answer in kilograms cancel, cubic meters cancel, in grams per cubic centimeter. And that works out to be 5.7 times 10 to the minus 3 grams per cubic centimeter. Don't forget the power there. You have to, if your units are cubed, you have to cube the conversion factor for those particular units. Okay, and then sometimes we might just have unknown units. So say, for example, I have this conversion factor. This is just 364.4 smoots, which is just this random measurement, is equal to 125 meters. Then I can use that to convert any measurement in meters to smoots. So if I have 225 meters, I say 125 here, 364.4 here, and that is equal to 656 meters. A Smoot is actually a scientist that he's still alive, but he won the Nobel Prize back in the 70s or 80s, I think. But when he was an undergraduate, they used him to measure the length across this bridge in Boston. And so they made a unit of measurement out of him, a Smoot. They ever do that for y'all? It was like his fraternity. Any of your fraternities ever do that? Like measure the lengths of things in one of your pledges or whatever? No? Okay. I'm not sure you're allowed to do that anyway. So. Okay, let's do estimates and orders of magnitude. Listen, with the estimates, you'll see this, and students always have trouble with this, but, well, not always. Some students sometimes have trouble with this. Whenever I ask you to estimate something, you're always looking to get it within a factor of 10. And in order to do that, you need to know a few basic measurements. You need to know what a meter is. Right, a meter is a few feet. It's about this long. It's about the length, you know, from here out to the tip of your arm. It's about 3 feet long. You also need to know, goodness, you also need to know what a centimeter is. I always like to think of a centimeter as like the width of my pinky. A centimeter is about the width of your pinky. It's a hundredth of a meter and about the width of your pinky. A kilometer is, gosh, what is a kilometer in miles? Well, it's 1,000 meters, so it's about 3,000, or it's 1,000 meters. So a meter is about 3 feet. A centimeter is about your pinky width. A kilometer, well, that's 1,000 meters or 3,000 feet. That's a little more than half a mile. Kilogram, how many pounds is a kilogram, roughly? It's about 2. It's a little more than 2. So a kilogram is about 2 pounds. And then a gram, you know, it's about the mass of a penny. It's less than a penny. I think a penny is actually 2 or 3 grams. Okay, so you just need to have physical ideas of what those measurements are, and then on the test, and you can look back at the old exams. By the way, anybody, don't raise your hand, but you should be looking at the old exams. They're good practice for you as you go along. Again, you should be setting aside 30 minutes a day maybe, working on practice problems, doing your quiz, doing the old test, doing your homework. 30 minutes a day is probably a pretty good guideline. If you're having trouble struggling, you might need to bump that up to an hour or so a day. Okay? So for example, I'll give you something that you can see on the test, and I'll ask you, so what is the volume of this room? Well, gosh, we can estimate the volume of the room. We just need the length, width, and height. How many meters across do you think? Don't try to count. Well, you could count the tiles if you want, but if you were to just estimate the length of this room, what would you say roughly? 10, that'd be about 30 feet. Yeah. 10 is probably a little light, but yeah, I'm going to say 20. Is that okay? 20 is probably, well, you can count the tiles. No, you're closer, I think. I don't know who said 10. Brennan? Yeah, so 10, we'll say 10 meters. So it's about 10 meters in this direction, and then in this direction, what is it? Ish. 40? Okay. I think that's probably a little high. 4 times the distance here to back there? Let's say 20. Can I say 20? All right, 25. I'm just going to say 20. And then how tall is it? About 3 meters. I'm about 2 meters. It's about another meter up. So by about 3 meters. So now we have a good rough measurement. 2,000 or 10 times 20 is 200 times 3. That's 600 cubic meters. So on a test, I would be multiple choice, and I would say, what is the volume of this room? And I would give you options. I would say, is it 6 cubic meters? And you'd say, wait, you crazy? Is it 60 cubic meters? This room would have to be like 6 by 10 by 1 in order to be 60 cubic meters. It would just be like this little section right over here. Or is it 600 cubic meters? Or is it 6,000 cubic meters? So those would be the options that you would have on the test for something like that. Is it 6, 60, 6,000, or 600 or 6,000? And then you would say these answers are just not reasonable at all, but this is the only reasonable answer. So if you have any idea what those measurements are, you should be able to pick out which ones are reasonable and which ones are not reasonable. Can you see how 600 is really the only reasonable answer? A 6,000 cubic meter room, that would take this room, 10 of them. It would have to be 10 times the size of this room in order to be 6,000. So that's not a reasonable answer either. The mass of your head, does anybody measure the mass of their head lately? I don't know, how much does your head weigh? How much? 10 pounds, 15 pounds maybe, 20 pounds? Do you know? 10 pounds? So how many kilograms? If I were to give you options and I said, does your head weigh a half a kilogram, 5 kilograms, 50 kilograms, or 500 kilograms, what would you say? You would say 5, right? Because that would be roughly 10 pounds. So you need to relate quantities that you do know to these metric system quantities. And then the area of your desktop, well, I'll let you do that on your own. But if you look back at the old test, you can see some different questions like that. But it'll be similar to that, where I give you something that you can see or something that you know very commonly and ask you what is the area of it, what is the height of it, what is the length of it, what is the mass of it. What's a typical person? The mass of a typical person in kilograms. Is it 7 kilograms, 70 kilograms, 700 kilograms, or 7,000 kilograms? 70 kilograms. That's a typical person. That's about 160, 170 pounds. Okay. Let's try this. This is from an old test. What is the area of this projection screen? This screen, is it 1, 10, 100, or 1,000 square meters? All right, I'm going to stop at 30 seconds. 30 seconds. Remember, you can ask your neighbor if you like. Almost everybody has the right answer. All right, awesome. B is the right answer. It's 10 square meters. A 1 square meter screen would be 1 meter by 1 meter. So this would be like a 1 square meter screen. A 100 square meter screen would be 10 by 10 meters. That would be 30 feet by 30 feet. All right, this is only maybe a couple meters. So we have to pick an answer that's in between about 10 meters squared. This is roughly, 2 by 4, or 3 by 3. It's closer to 10 than any one of the other answers. All right? Do you know why cows always make good scientists? Because they're always outstanding in their fields. Right. That was very good. Yeah, that was very good. Okay, coordinate systems. You guys should know this. Let's just, I'm going to go through it quickly and we'll see some questions about it later. We're going to use a Cartesian coordinate system most of the time. Occasionally we'll use a polar coordinate system. In a Cartesian coordinate system, we'll mainly use 2 dimensions where we have x and y coordinates. We usually give the x coordinate first and the y coordinate next. X and y coordinates. The origin here is where x equals 0, y equals 0. Yes, y'all know this? Yes? Okay. It will help you to know your quadrants because I'll sometimes refer to them. You may or may not remember this. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. When we're measuring angles in a coordinate system, we always start with the x-axis and we go in this direction. Unless I say otherwise, and we'll see that with vectors, that sometimes we'll define our angles based on other axes, but the default is always to define them from the positive x-axis. Positive is to the right, negative is to the left, because we live in this right-handed world. Like literally, we have a right-handed coordinate system. Up is down, up is positive, down is negative. We'll also later, like chapter 7 or 8, we'll get into some three-dimensional stuff when we do rotation, where we'll have a z-axis. You've probably seen that before, but the z-axis, y, x, z is that third dimension. Not sweat that right now. We'll deal with that in about 7 chapters. There is sometimes we'll use the plane polar coordinate system, where instead of using x and y coordinates, we use r and theta. Actually, no, we're not going to use the plane polar coordinate system, but you do need to know how to deal with your r and your theta doing the trigonometry, which I'll show you in just a bit. Okay? We will talk about theta in chapter 7 as things rotate around, but we're not going to use this particular method of defining a point in space. But you should have had that in high school math or here in math. This is all the trig that you're going to need. Trigonometry is usually a prerequisite, though most of you are in Calc 1, you probably didn't even take trig here. But in trigonometry, you have to learn all those identities and all those crazy things in trig. Y'all remember all that crazy stuff? Yeah, really all you got to know is the Pythagorean theorem. Who knows the Pythagorean theorem? Yeah. And SOHCAHTOA, or whatever mnemonic you learn. Y'all know what I mean? SOHCAHTOA, whatever. That's really all you need to know, but you need to know how to apply those. It's okay if you don't know how to do those things right now, but come time for the test, it's not good for you to not know how to do that, because we're going to use right-angle trigonometry the entire semester, and next semester too. So make sure that you're good on this. I'll give you the rundown here. So imagine we have a triangle. It's a right triangle with a right angle here. I can define relationships between theta and the different sides, and that's what this SOHCAHTOA is. The sine of the angle, that's S, is equal to opposite over a hypotenuse. When I'm talking about an angle theta, this is the opposite side, the side that's opposite where that angle is measured. And in this case, it's going to be y over h, or y over r, excuse me. This is my hypotenuse. It's the side that's opposite the 90-degree angle. Cosine is adjacent over hypotenuse. That's going to be x in this case over r. And then tangent is opposite over adjacent. That is y over x. You need to know this cold because we're going to use it a lot, especially in the next chapter. And you need to know how to just look at a right triangle and say, oh, I need to use the cosine for that, or oh, I need to use the sine for that. So if you don't know it cold now, you need to get it by, tonight really. You need to know your trig functions really well. It's just these three, but just know that when you look at a triangle, when to apply which one. And then you also need to know the Pythagorean theorem. For a given triangle, I'll label it a little bit differently. This is probably how you're used to seeing it. A right triangle ABC. Pythagorean theorem is a squared plus b squared equals what? C squared, right? So y'all have seen that. We'll use it in chapter 3 when we get into vectors. Okay? You use it a lot. And then from then on, we'll use trig functions a lot. You'll always use degree mode. I know that a lot of you are in calculus right now, Calc 1, and in that class, sometimes you'll use radian mode on your calculator, but you should use it degree mode here. Okie dokie? What mode are you going to use on your calculator? I don't know how many questions I missed in college because my calculator was in the wrong mode. And then like my very last year in college, I put a little sticker up at the top of it that said, check the mode before every test. But we'll always be in degree mode. Yes, we will always be in degree mode for this class. Even though later we will use radians, you'll still keep your calculator in degree mode. Sometimes we need to find the angle theta. So say, for example, I have a triangle that is a 3, 4. Gosh, what would the hypotenuse be in this case? That's a special triangle. I like to use special triangles because, they're special and they deserve our reverence. Let's just take a minute. Whoa. Okay. And they're easy to use because we know the numbers. We don't have to go through all the trig to get what we need. But let's say I want to find this angle right here. I could do that by saying the tangent of theta. Let's see, SOHCAHTOA, OA. That's opposite over adjacent. In this case, the numbers would be opposite would be 4 over. That's right. So to find theta, I would do the inverse tan of 4 over 3. You can think of this as sort of, I'm taking the inverse tan of this side, and it gets rid of that, and then I do the inverse tan of this side. I do the same operation to both sides. And that'll give me the angle. Gosh, what is that angle on a 3, 4, 5 triangle? Huh? 30. No, you're thinking of a 30, 60, 90 triangle. This is this is 53 degrees and this is 37 degrees. You don't believe me, you just worked it out. But this is 53 degrees. Alrighty? Hopefully that's all reviewed for you. That's why I'm kind of going fast. Any questions though, folks? I don't want to dwell too long on this, but it is important because we'll use it all year. Alrighty? Let's do a quick test. So here I have this, have to blow out a little bit. Wait, I'm just going to write it here. I understand that y'all haven't gotten your workbooks yet. Has anybody gotten theirs? No? Oh, you got yours? Okay, well, hopefully they'll be coming in soon. It'll be a lot easier for you to follow along in class because all these questions are in there. So let's say on this one, I want you to tell me what is the value for R. Is it A, 6.0 meters? Is it B, 4.3 meters? Or is it C, 19 meters? What is the value for R? R is the distance from the origin to here. I'm going to go ahead and start the clicker on this. Go ahead and put in your answer. The second question I'm going to ask is what is theta? But you go ahead and find R. And I'm going to put the options for theta up here. And I'll start the clicker base in just a second for that.
stop it.
Right. Right now I'm asking the question, what is R? You need to find out what is the value for R, and then in just a moment I'll ask you what is the value for theta. Right now, what is R? If you found R, go ahead and look it in. I'm going to stop in about 8 seconds, 140, and then go ahead and figure out what theta is. I'll stop it at 140, see what you got. Look it up pretty well. Okay, awesome. B is right. You can do this by drawing a triangle here and here. I get this side is, see, y is what, 2.5? So this side is 2.5 and this side is 3.5. And you do the square root of 2.5 squared plus 3.5 squared, and that's going to be 4.3 meters. All right? We'll count this as 2 questions. If you get the next one, I'll give you a joke. Okay? The next one is, what is theta? You can try calculating this, but you should also just try reasoning out what the answer is. Often on my test, you can, not on all the questions, but on some of the questions, you can figure out the answer just by eliminating those answers that are not logical or not reasonable. All right, I'll stop at 40 seconds. 40 seconds. I'll go 42. Okay, C is the right answer. Why could we just look at those options and say it has to be C? Why is that? Right, because it has to be in which quadrant? It has to be in the third quadrant, right? And in the third quadrant, it goes from 180 to 270, so it has to be somewhere between 180 and 270. You could also figure out what this angle is, or I'll call it not theta, but I'll call it phi. I could say that phi is the inverse tan of opposite over adjacent, 2.5 over 3.5, and you would find that that's equal to 36 degrees. And then to find theta, you would say theta is 180 plus 36, which is 216. But in this case, you don't need to really go through that, because you can just look at it and say, well, it has to be 216 because it's in the third quadrant. All right? I'm about to give you some good advice. Y'all ready for it? What should you do if you're attacked by a group of clowns? Go for the jugular. That's good advice. That's my advice to you. And don't go to jail. That's what I tell my kids. Don't go to jail, because generally that's bad. Go for the jugular. All right. We still have some more questions here. We did these. Did we do this? I don't think we did. Listen, after today, these slides and your the solutions will be online on the website. On the website, there's a link that says Concept Test, and you can go and you can look at it there. You can download it with the answers. These are a good guide to study for the test, because you will have questions that will be similar to these. Sometimes I'll just pull questions straight off of these, but usually I change them up a little bit. Okay? They're on the course website, and they'll be in your textbook. And if you have their workbook, rather, it's in the very back of the workbook when you get it. So you can record the answer as we're going along. Okay, so let's try this. Here we have x is equal to a times v. What are the dimensions of a? X is position, measured in meters. V is speed or velocity, measured in meters per second. What are the dimensions of that constant a? A is not area or acceleration necessarily, but what are the dimensions of a? It could be area or acceleration, but not necessarily, not just. Feel free to ask your neighbor what they put. Why did you find? Okay, that's how you do it. So we'll stop in about 8 seconds at 1:15. 1:15. Okay, awesome. C is right. A couple of different ways you can think about this. You can say, well, X is in meters. V is in meters per second. What must the units here be? Well, it has to be seconds. All right. Or you could solve this for A. You could say A is equal to X over V. That's meters over seconds. That's meters times seconds over meters. That all cancels and gives you seconds. So a couple of different ways you can think about that. You'll certainly see some dimensional analysis questions on the test. 2 or 3 questions where I give you some equations, ask you, are they dimensionally correct or not, like we've done in class, or what are the dimensions of this equation? All right, here you have a 1 by 1.2 by 0.8 meter crate, and I want to know what is the volume in cubic feet. Try doing this without your calculator. You can use your calculator, but you can probably do it without it too, by just rounding off numbers. Check your answer with your neighbor. All right, we'll stop at 120. 120, that's 5 more seconds. All right, A is right. Just want to tell you, I know that it's kind of fast going through these questions. That's intentional because on the test you need to be really fast. And it's okay for you to get the answer wrong here. If you get the answer wrong here, that's not really that big of a deal. These questions are really sort of for you to make sure that you're engaged in class and participating. If you miss, oh gosh, if you miss half the questions, you still get full credit. So don't sweat it if you miss a lot of questions. If you're missing all the questions, you really should see me. Well, I'll help you. But if you're missing, a third of the questions, who cares, right? Who cares? I mean, I care because that's who I am. But I don't want you to sweat it too much. Anyway, so here I have 1 by 1.2 by 0.8. To find the volume in cubic meters, I can just look at it and tell you that it's approximately equal to 1. Because I can round down 1.2 and round up 0.8. In fact, I think it is roughly 1, isn't it? What is it? You see, y'all were using your calculators, weren't you? That's okay, double check, that's okay. So I have 1 cubic meter, and so 1 cubic meter, I want to convert that to cubic feet. I know in 1 meter, there are 3.28 feet. And some of you put D, because you stopped at this point, but D is not right. Yeah, D is like the second most popular answer. I have to cube this in order to make these cancel, or excuse me, make these cancel out properly. 3 cubed is 27, so the one that's closest to 27 is going to be our answer. Or 3.28 cubed is 34. Okay? All right. A jet airplane climbs at an angle of 15 degrees with respect to the horizontal and follows a straight line path for a distance of 400 meters. That means that your airplane down here, it follows, it looks like a butterfly, doesn't it? It follows a path that's this. It goes 400 meters in this direction. That's what the straight line path means. So how much altitude does it gain? When it is at this point, what is its altitude? Your answer with your neighbor. I'm going to stop at 150. That's 5 more seconds. 150. Okay, good. A is right. This is what I mean. You really need to look at this and say, boom, I need to use the sine function, okay? So you need to be able to know that really quickly on your feet, because on the test, you're not going to have a whole lot of time to go through, let's see, sine, cosine. You're not really going to have time for all that. You need to be able to look at this and say, I want to know this, I know this, oh, that's my sine function. And then you can say sine of 15 equals y over 400. Or hopefully you'll just be able to skip right ahead, that when you see this triangle that you'll say y is 400 sine 15. Don't worry, you'll be there eventually, because we're going to use the trig functions a lot. You'll be there if you're not there yet. And 400 times sine of 15 is 100 meters. Oh, I like these. So consider this expression, y equals x squared. Which one of these statements is most consistent with that expression? Which one of these is always true? Alright, I'll stop at 110. They're doing better than I expected, but we're still sort of all over the board. 110, I'll stop. 5 more seconds. These types of problems you'll see a lot. In fact, they're common problems in that if you change one variable, how does the other variable change? It's an important idea to consider in physics as you're looking at a bunch of different equations that you're able to sort of put it into your mind. Well, if this variable changes in this way, it will change this variable in this way. Let's see, y'all put, so that's pretty good actually. D is the right answer. Let's go through these. A and B are both sort of commonly misheld ideas. If y doubles, then x quadruples. Let's write out this. I have y equals x squared. I'm going to put parentheses around this. If I double y, in order for this equation to still be the same, I have to do the same thing to this side. By how much is x going to increase if I double y? Not 2, not 4, not 1, not half, by root 2, by the square root of 2. Because the square root of 2 squared is equal to 2. Right, so if I double y, then x will increase by a factor of root 2, square root of 2. Also, so A is not right. B, y is greater than x. Y is equal to x squared. Let's test this. We'll just put in some numbers. If x is 2, y is 4. Right? That's greater. If x is 5, what is y? 25. Well, that's greater. If x is 10, what is y? Well, what if x is 1? What is y? Well, that's equal. But what if x is a half? What is y? What is it? A quarter. Is a half bigger or smaller than a quarter? It's bigger. So if x is less than 1, then y is less than x. Okay, so B is not correct. C is a linear relationship. If x doubles, y isn't going to double. In fact, D is the right answer. If x doubles, that means if I put a factor of 2 here, because it's squared, I get a factor of 4 over here. So D is the right answer. You're going to see a bunch of these this semester. You'll see in our, like in a lot of our clicker questions, you'll see these types of questions. Which of these is consistent with time to the -1? And here, this is a capital V, but it's still speed or velocity. It's meters per second. X is in meters, V is meters per second, and T is seconds. Try to do about 15 more seconds. Stop at 120, 120. Uh, 5 seconds. Okay, good. A is right. V over x, I'll just do the correct answer. V over x, that is meters per second over meters, or I can rewrite that as meters per second. 1 over meters, those cancel, and just leave me 1 over time, or time to the -1. Let's try this one. Which of these is consistent, or which of these has the same units as acceleration? Remember, V is meters per second, x is meters, t is seconds. Acceleration is meters per second squared. We're going to see that on Monday. But for now, just dealing with the units. Which of these is consistent with acceleration? Stop in about 15 seconds at 110. 110. I'll go to 15, 115. All right, D is right. When you get good with this, eventually you'll be able to just sort of do it in your head. Or if not, that's fine. You just write it out. But let's do the correct one here. V squared over x. That's meters per second, but it's squared. And because it's squared, we square both of them. Divided by meters. Or meters squared per second squared. 1 over meters. This cancels with that and leaves me with meters per second squared. You can try those others on your own if you want to see what their units are, but they're not the same as acceleration. Which of these points is nearest the y-axis? Think about your Cartesian coordinate system and what defines near or far away from the y-axis. Which of these points is nearest the y-axis? Not much longer. We'll do about 10 more seconds. Stopping at 40. Stopping now. Okay, good. D is right. When on my coordinate system, at -2, -5, I'm right here. When the x value is smallest, that's when I'm nearest the y-axis. I think you probably know that, but just think about our coordinate system. And do some sig figs. You will have 1 or 2 questions on the test about sig figs. Which of these is the appropriate answer? If you do in your calculator, you get this, 10.5 times 8.8 times 3.14. But what is the appropriate answer when multiplying digits? All right, I'll stop at 40. Stopping at 40. Awesome. A is right. I keep 2 sig figs because the 8.8 right here, it has 2 sig figs. When you're multiplying numbers, you keep the lowest number of significant figures. Do you know why people never die of starvation in the desert? Because of all the sandwiches there. Okay, the speed of a boat is given in knots. The speed of 5 knots were expressed in the SI system. What would the units be? I'll stop at 40. Let's see. That was easy. I'm not even sure that's not even joke worthy, is it? Oh. Okay, what's the worst thing about living on O Street?
What?
O Street.
What?
You gotta walk a whole block to pee. These are easy. We'll have harder questions later. Alright. Which of these is not dimensionally correct? So you have 4 equations. 3 of them are correct. 1 of them is not correct. Which one is it? Alright, I'm going to stop at 115, just a few more seconds. I'll go on to 120. 120. Okay, I think C is right. Is that right? Usually it's yeah, that's right. So all three of these are correct, and I'll leave you to try them on your own. But the third one, C, is meters per second on one side equals meters per second squared, 1 over seconds, that's that 1 over t, so it's meters per seconds cubed on the right-hand side. I think this is the last one. Yeah, these sig figs, what is the right answer? Alright, I'll stop at 30. Stopping at 30. Okay, good. D is right. And just want to encourage you that I know the first week of class, I'm in classes too, man. The professors are like, do this, and do this, and do this, and it's like, ah!